Good morning. Today we're going to learn on how to analyze our data by using ANOVA. In general, ANOVA has several methods for you to use or for you to choose to analyze your data. For example, in this tutorial, we will use two-way of ANOVA to analyze our data. But before you proceed with this method, you have to make some assumptions or several assumptions. The first assumption is the study must have a continuous dependent variable. The second one, the study must have two independent variables that are both categorical with two or more groups in each independent variable. And the third one, the study must have independent observation. Let's see the conceptual framework or research framework in this study. So for the conceptual framework, we have independent variable, which is learning intervention that has two groups. The first group is a group of students study or learn 3D with AI that categorized as a group group A. And the second one, a group of students that learn 3D without AI categorized as a group B. And we have moderator variables here, which is prior knowledge. We have high and low prior knowledge, and we have dependent variable here. The dependent variable is a variable that you want to measure. For example, the level of interest, level of engagement, and academic performance. So let's see the first assumption. The study must have a continuous dependent variable. If you can see here, the dependent variable should be measured continuously. Means after you measure your interest, followed by the level of engagement, and the last one, academic performance, must be continuously observed or measured. And the second one, for the second assumption, the student must have two independent variables that are both categorical with two or more groups. If you can see, the first independent variable is learning intervention that has two groups, A and B. So it made the first one category, both are categorical with two or more groups. So the first independent variable has two groups, A and B. However, the moderator variables in certain cases of study can act as the second independent variable. This is mentioned by Late Statistic 2025, Creswell 2018, where in certain cases the moderator variable can act as a second independent variable. So let's see for the moderator variable, which is as known as second independent variable. So we have two groups here, prior knowledge, high and low. So the total for both independent variables, the first one and the second one, we have four groups here, which means group A, group A with high prior knowledge and group A with low prior knowledge. Also, group B with high prior knowledge and group B with 4 prior knowledge. So the total of group here should be 4. Now, okay, so if we refer to this second assumption, two independent variables that are both categorical with two or more groups. So we have two independent variables here that have two groups for each variable. Okay, so now we proceed with the third one. The study must have independent observation, which means group A, either group A high prior knowledge or group A low prior knowledge, must be observed independently with group B with high prior knowledge and group B with low prior knowledge. Both groups are observed independently. Okay, so now after all these assumptions are met, so you have to conduct your descriptive analysis to find mean, mode, range, standard deviation, min, max, variance, and also normality test, including Lebanese test, to see either your variance of these groups has equal or similar or not, and to see either you have extreme outliers or not before you can proceed with these fourth, fifth, and sixth assumptions. So now let's see, or let's conduct our descriptive analysis by using SPSS.
So once you open your SPSS and click on this variable view, so what we're gonna do now is to add the column for your data. We have 4 columns here. The first column is student code. Okay, name it as a student code, and please change the data type from numeric to string, and then click OK. And for the measurement, choose nominal. For the intervention, name it as intervention and let the data type as a numeric. And for the values, click on these 3 dots and label it 1 for group E, 2 for group B, and then click OK. Please make sure your measurement is nominal. And then the third column is prior knowledge. Let the data type as numeric. Same goes to intervention, and click on these 3 dots and the values and label it 1 for low and 2 for high prior knowledge. And for the measurement, click ordinal. And the last one is your interest or your dependent variable or your variables. If you have 3 variables, please put it together. Interest, for example, engagement here, and academic performance, for example. But we will analyze one by one. So in these cases, we will analyze the interest only. So name it as interest and let it the data type as numeric and choose measurement, choose scale for your measurement. Okay, once you finish this one and click your data view, you will have 1, 2, 3, 4 columns. So please import your data from your Excel, okay, into this SPSS. For example, in this student code, I name it as GEL, stands for Group A with low prior knowledge, and GAH stands for group E with high prior knowledge, and GBL, group B with low prior knowledge. And the last one, GBH, group B for high prior knowledge. So if you have 120 students, you must import all the 120 students data in this SPSS. Okay, so the intervention, you just click 1, so it will display as group A, and click or input 2, and then it will display as group B. If your intervention or your data here shows a number, please go to these value labels, this one, and then click on it, and it will display as group. Same goes to prior knowledge. Okay, now we are moving for the last column, which is your variable, dependent variable. So in this case, we use interest. So please make sure your data here, your dependent variable data, has been cleaning. Okay, for example, I clean this one by subtract it from post and pre. For example, I have post data and then I subtract with pre data to get the gain of interest. So what you see here is the cleaning data. Okay, and now we want to analyze by using two-way of ANOVA. What you should do is, it is different from PET t-test or sample or independent sample t-test, because we have to analyze the two-way ANOVA first before we conducting the descriptive analysis, because we want to find the residual analysis. Okay, now click on analyze and find for general linear model and click on univariate. So you will have dependent variable here, fixed factors, random factors, covariate, and WLS weight. So please choose the first one is your dependent variable, which is your interest, and click move to dependent variable. And then your intervention, click on it and move to fixed factors. Also prior knowledge here, move to fixed factors. So on the right side, you will have model contrast plots, post hoc, EM, means, safe, options, bootstrap. So click on model, let it be default. Click on contrast, also let it be default, and click continue. And the last one, plots. So you will have factors and horizontal axis, also separate lines. So click on intervention, the first factor, and move into horizontal axis. For prior knowledge, click on it and move to separate lines, and then click add. So now we have intervention against prior knowledge. So you need to vice versa the plots. So click prior knowledge and move to horizontal axis, and click intervention, move to separate lines, and click add. So now we have two plots, intervention against prior knowledge and prior knowledge against intervention. So click continue. For post hoc, click on post hoc and move all these factors to post hoc test. Click for intervention, and prior knowledge. And for equal variance assume, please click for Bonferroni. This one, Bonferroni. Click continue and click for EM means. It stands for estimated marginal means. Click on intervention, move to display means, prior knowledge, move to display means, and intervention against prior knowledge, move to display means. And please click on compare main effects and compare simple main effects. And please, for confidence interval adjustment, click on Bonferroni. Then click continue. So the last one is option. You will have you have to click on 4 options. For example, this one, descriptive statistic, estimates of effect size, and click for homogeneity test and residual plots. Click continue. And then click on this save. So for this option, we will have predicted values and residuals. For predicted values, click on unstandardized, and for residuals, click on unstandardized and studentized. Then click continue. Once you're satisfied with your settings, and then click OK. And now you will see the result. Okay, I will go through the result one by one later. So open your data sheet again, and you will see you will have 3 column, the new 3 column. Okay, the first one is pre, stands for predicted value for interest. Second one is res, stands for a residual for interest, and the last one, studentized residual for interest. Okay, now what we're going to do is to conduct the statistic or descriptive analysis. So first, go to this data tab, click on split file, and you will see the first one is analyze all cases, do not create groups. And the second option, compare groups, and the last one, organize output by groups. So please click the second one, compare groups. So please bring the intervention and prior knowledge into this group based on. Okay, because we want to compare or to analyze, to conduct the descriptive analysis by analyzing the interest level of students in this intervention and prior knowledge. For example, we want to see the level of interest in group A for low prior knowledge. We want to see level of interest in group A for high prior knowledge. And we want to see level of interest in group B for low prior knowledge, and level of interest in group B for high prior knowledge. Also, we want to see the comparison between level of interest in group A and B only. Okay, so now click OK. Okay, we're done. Okay, now click on analyze again and choose descriptive statistics, and then click explore. So in these settings, For dependent list, please choose residual for interest. And for factor list, choose intervention and prior knowledge. For statistics, please check for descriptives and outliers because we want to find out either our data meet the fourth, fifth, and sixth assumption or not. So one of it is the outliers. Okay, click continue. For plots, check for factor levels together, and descriptive, click histogram. Don't forget to check on these normality plots with test. Okay, then click continue. So for option, let it be default. Same goes to bootstrap. So now click OK. You will have this kind of data analysis. And now I will go through one by one. Okay, now let's go through the result one by one. However, to interpret your data, you have to interpret the descriptive analysis first. Okay, and look at this hierarchy. So we have explore here. So this explore is considered as your descriptive analysis, and it's divided into two terms, which is intervention and prior knowledge. So let's see for the intervention first. So we have this descriptive table with low prior knowledge, high and low, which is the prior knowledge, high and low for group A and group B. Okay, the first one is low prior knowledge of residual for interest in both intervention A and B, and the second one we have high prior knowledge of residual of interest for group A and group B. So you can see the mean, the variance here, standard deviation, minimum and maximum range, interquartile, and skewness, also kurtosis for both prior knowledge, low and high. And then we scroll down, we have extreme values here. Scroll down, and then this normality. So please make sure that we want to find either our result or our data are normally distributed or not. So to get that, or to determine whether our data is normally distributed or not, so you have to look at this Shapiro wheel. Okay, for example, for low prior knowledge for group A, we have 0.544, and for group B, we have 0.066. For high prior knowledge, for group A, we have 0.284, and group B 0.310, which means once your Shapiro wheel result shows the significance different, p-value is greater than 0.05, and it considered as normally distributed. So we met the assumption. The fifth one is your outliers. Okay, scroll down until you find your box plot here. So if you can see, for intervention group A, low prior knowledge, we don't have any extreme outliers here. Same goes to group A with high prior knowledge. Also, we don't have any outliers here. And same goes to group B for low prior knowledge and group B for high prior knowledge. There is no outliers here. Okay, So for the intervention, we met the fifth assumptions, which is there is no outliers. So we have to check for the prior knowledge. So click on this prior knowledge. Okay, again, go to this descriptive. So this is your descriptive result for prior knowledge. For prior knowledge. So we have intervention group A with low prior knowledge, and intervention also for high, and group B for low intervention or for low prior knowledge, and for group B for high prior knowledge. So scroll down. So for the normality test, okay, for group A for low prior knowledge, we got the Shapiro-Wilk result, which is p-value 0.544. For height, 0.284. For group B, low prior knowledge, we have 0.66. For group B, high prior knowledge, 0.310. So all these data shows that p-value higher than 0.05 and consider as normal. So now scroll down. You want to see the fifth assumptions, which is outliers, extreme outliers. Okay, for intervention group A with low prior knowledge, there is no outliers, extreme outliers in this box plot. Same goes to group A with high prior knowledge, and group B for low prior knowledge and high prior knowledge also we can see there is no outliers. So we met the fifth assumptions for intervention and prior knowledge. Now we want to see the homogeneity test by using Lebanese test. So what you're gonna do now, go to this univariate analysis variance, okay, the ANOVA test just now, and click on it, and then you can see this is the descriptive analysis or descriptive statistics, and please go to this one, Lebanese test of equality of error variances. So we can see based on mean here, the result p-value is less than 0.05, which is we got 0.001, and it is not homogeneity variance, so it is violated. So what we're gonna do, we have to find the heterogeneity or heterogeneous test. Okay, now click on this graph. Okay, choose scatter. Click on simple scatter. Click define. So we want to see the first one is residual for interest for y-axis against predicted value for interest for x-axis. Click OK. So you will have graph, the first graph like this, and the second one again repeat the same steps. Click on graphs, scatter, choose simple scatter, click define. You now just change the y-axis to studentized residual for interest against predicted value for interest, and then click OK. So if you can see here, both graphs have same pattern. Once you get the same patterns, then you can conclude that these data for these two groups has or have equal or similar variances, which means the data that we get is homogeneous variance, and it is similar for both groups. So we met the last assumptions for ANOVA. Now we want to see the main effect for both intervention and prior knowledge. For example, we want to see, are there any statistically significant between group A and group B? Also, are they statistically significant for group for low prior knowledge and for high prior knowledge? Okay, if you get this kind of graph, which is parallel between two groups, means that your result or this interest is not statistically significant. You only get the data that's statistically significant once you got this kind of data or this kind of graph. Okay, to double check, you can go to scroll up first, and you can go to here, test between subject. So let's see for the intervention. Okay, for the intervention, you will get 0.11 for p-value, which is less than 0.05, and for the prior knowledge also you get 0.001, which is less than 0.5. But for the intervention against this one, intervention against prior knowledge, you get 0.746, which means your result or your data or the interest among the students is not statistically significant because is greater than 0. Because it is greater than 0.05. So we get 0.746. Okay, next, to interpret between the intervention. So let's see the first pair, group A and group B. Statistically significant because we get p-value 0.011. Also for the intervention, group B against group A, we get 0.011 for the p-value. Then you scroll down. So this one for intervention. So we want to see for prior knowledge. So for low and high prior knowledge, again, we have statistically significant where we get p-value 0.001, which is less than 0.05, and also high compared to low prior knowledge, we got 0.001 and which is less than 0.05, and it is significantly or statistically significant. Next, we want to compare this one. So let's see for prior knowledge, group A and group B. Okay, we want to see either there is a significant difference for students in group A and group B in low prior knowledge. So we got statistically not significant because the p-value is 0.112, less than 0.05. Same goes to the level of interest between group A and group B for high prior knowledge. Okay, group A and group B for high prior knowledge. So we have 0.042 here, which means it is statistically significant because it has less than 0.05. So what can we conclude? So for high prior knowledge between group A and group B, there is a significant difference between both of group. For low prior knowledge, there is no significant difference between group A and group B. Then we scroll down again. Okay, that one intervention against prior knowledge. So now we want to see the second one is the prior knowledge and the intervention. Okay, let's see this one. So now we want to see, are there any significant difference between low prior knowledge and high prior knowledge in group A? And are they, or is there any significant difference between low prior knowledge and high prior knowledge in group B? Okay, so this one we get less than 0.05, and also this one we get less than 0.05. So both are significantly different. So how to conclude? There is a significant difference between low and high prior knowledge in group A. Also, we have significant difference between low and high prior knowledge in group B. Okay, so that's all from me for this two-way of ANOVA. If you want to see how to interpret in a proper way, you can go to this link I give you. Thank you.